Hello, everybody.
Hello.
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 Just we could start. We have our first participant, Igor Safronov from Russia. Igor, you have the floor.
Hello, can you hear me? Can you see me?
Yes, we can hear you and we can see you.
All right, let's get right into it. Can you see it now?
Yeah.
Cool. Good afternoon, dear members of the Expert Commission and conference participants. My name is Igor Safronov, and I would like to draw your attention to a research work entitled Study of the Temperature Dependence of a Heated Body on the Blowing Speed. Many of us know that overheating spoils things. During the operation of semiconductor devices, a rather large amount of heat is released, as a result of which the temperature rises, or in other words, the device overheats and may fail. To solve this problem, let us turn to the convective method of heat exchange, air cooling. But how can you minimize the consumption of electrical energy while maintaining the efficiency of cooling the device? This work is aimed at studying the change in the temperature of the heated body with the determination of the optimal parameters of the blowing speed in industrial installations. The issue of energy saving in increasing the efficiency of the industry remains relevant to this day. To date, various design schemes of heat exchange have been developed for use in heating systems and utilization of air heat. Since 2010, the Russian Federation has accepted a state program for energy conservation and efficiency improvement, which will reduce the energy intensity of the Russian Federation gross domestic product. This program remains relevant at the moment. Besides, the problems of power supply and cooling systems in corporate data centers today are faced not only by technical specialists and administration, but also by ordinary corporate users, representatives of small businesses and industry. The reason for these problems is the mismatch between the widespread explosive growth in the number of servers and storage systems with their ever-increasing performance, as well as the limited ability to implement cost-effective solutions in most data centers. Also, the question arose of the need to introduce efficient cooling systems in the industry. Metallurgy is a great example for it. In the course of our work, the following hypothesis was put forward. The efficiency of intensification of heat exchange processes in a gas flow depends on the optimally selected blowing speed. To confirm or refute this hypothesis, we set the goal of developing an experimental setup for measuring the change in the temperature of a heated body from the blowing speed. To achieve this goal, we need to solve the following series of objectives. These include the creation of an experimental setup for measuring the change in the temperature of a heated body from the blowing speed, as well as justification of the possibility of applying the acquired knowledge in practice. Heat transfer is the process of transferring heat, that is the exchange of energy. There are three types of heat transfer in total. Thermal conductivity, which is a heat transfer from more heated areas of solids to less heated ones. Convection, heat transfer by jets of liquids or gases. And radiation, heat transfer by means of electromagnetic waves. The types of heat transfer without mass transfer include thermal conductivity and radiation, and heat transfer with mass transfer includes natural convection and forced airflow, which is also called forced convection. The natural convection occurs spontaneously in a substance when it is unevenly heated, while during forced convection, the material movement is due to the action of external forces, such as pump, fan blades, etc. Since our study refers to the intensification of heat transfer by means of blowing, let us dwell in more detail on the consideration of the theory of forced convection. This formula is used to describe the convective heat transfer. The heat flux density on the surface is directly proportional to the multiplication of the heat transfer coefficient and the temperature difference. The heat transfer coefficient increases with an increase in the velocity of the medium and during the transition from a laminar to a turbulent regime of motion in connection with the intensification of convective transfer. The heat transfer coefficient is also higher for those media with a higher thermal conductivity coefficient. In most cases encountered in practice, the heat transfer coefficient is determined experimentally. The subject of our research was a heated body and the object, a laboratory setup for recording measurements. In laboratory condition, we have assembled a total of 3 experimental setups. This slide shows the first of them, consisting of a ceramic tube rheostat, digital thermometer, an electricity source, an airflow source, and anemometer, a device for measuring wind speed. First of all, we measured the room temperature equal to 22 degrees. Then we set a constant current supply to the electricity source equal to 7 volts, 7 watts, and 1 ampere. As a result, our body was warmed up to a constant temperature of 90 degrees. Next, we turned on the airflow source and measured the temperature of the cooling body by changing the airflow rate. The measurement results are listed in the table. And in it, you can immediately notice that starting from the 7th test, the temperature of the cooled body began to decrease slightly. Let's present this result on the graph. Indeed, based on the results obtained, we have drawn up a graph having obtained an inverse exponential dependence of the temperature difference on the blowing speed. Let's go a little deeper into its essence. 10 points are marked on it. The first one shows the difference between room and maximum temperatures of a heated body, which in turn is equal to 68 degrees Celsius. Then the 9 lower points represent the difference between the room and minimum temperatures of each experiment. From the graph, we also see that starting from a speed of 4 meters per second, the exponent is almost exactly parallel to the x-axis, showing a result of 7 degrees. In other words, starting from a speed of 4 meters per second, the body temperature will not drop below. Regardless of the increase in the blowing speed, the body, taking into account the difference in room temperature, will still be cooled to a minimum of 7 degrees Celsius. Therefore, the optimal speed for this configuration will be 4 to 5 meters per second. Now, let's find the inverse of the temperature difference and plot the dependence of the inverse temperature difference on the blowing speed in order to derive a formula for finding the margin of error in determining the speed. Well, the graph is built. Now let's derive the formulas. By transforming the formula obtained from the graph for the dependence of the inverse temperature difference on the blowing speed and deriving the formula for the velocity, we were able to derive a formula for determining the speed margin of error. The second experiment consisted of thermostating. To create the second setup, we needed a thermostat, a device for maintaining a constant body temperature, heated body. Based on the heat conducting qualities of metals, we chose brass, source of airflow, and anemometer. On the thermostat, we set the maintenance of a constant body temperature at 60 degrees. Then it was subjected to a series of experiments in which we observed how the power of the electric current supplied by the thermostat to the body changes in order to maintain its constant temperature under the influence of wind flows of different speeds. The results of the experiments are presented in the table on the slide. Let's present them in the form of a graph. Based on the quantitative indicators, a graph was drawn up and linear dependence of the power on the blowing speed was obtained. Therefore, according to the graph, it is easy to determine the optimal blowing speed for a given power in the proposed configuration. For example, we were told to maintain a constant temperature of a given body at 60 degrees Celsius. However, at the same time using a power equal to 12 watts. Based on our graph, we have drawn a parallel from the power column to the moment of its intersection with the linear relationship. And from the point of intersection, we have drawn a parallel to the x-axis. As a result, this gives us that for a power equal to 12 watts, the optimal blowing speed will be approximately 2.5 meters per second. Changing the temperature parameters to higher ones, a similar experiment was carried out, the results of which are presented in the table. Based on its results, a graph was also drawn up and linear dependence of the power on the blowing speed was obtained, by which we can also easily determine the optimal speed for a given power. Experimental setup number 3 consisted of a thermostat, a heated body, a source of operating on blowing, and a source of airflow. We have constructed a separate setup for it, consisting of a vacuum cleaner operating on blowing, and a linear auto transformer for adjusting the wind speed, and actually anemometer. The principle of this experiment was similar to the first one. We set constant power on the thermostat and recorded the change in body temperature under the influence of airflows of different speeds. The results are presented in the table, where we also noticed that after the 7th test, the minimum temperature changes insignificantly. Next, we presented the results on the inverse exponential dependence of the temperature difference on the blowing speed, from which we can conclude that the optimal speed will be 6 to 7 meters per second. The final experiment was carried out according to the same principle, while the temperature was significantly higher, 123 degrees Celsius. The results are presented in the table. However, in this experiment, only after the 10th test, the minimum temperature began to drop slightly, and then completely stopped decreasing. From the graph, you can see that the optimal speed will be 9 to 10 meters per second. Consequently, the higher the temperature of the heated body, the higher its optimal blowing speed will be. Based on the results of the experiment and experiments carried out, we can safely say that the hypothesis put forward by us has been confirmed. Each of these configurations has its own optimum airflow speed. With a little effort, we can calculate this speed in order to use electrical energy efficiently without unnecessary waste. Based on the knowledge gained, the prospects for our project are to create our own cooling unit, which will automatically adjust the blowing speed to the consumed power in order to maintain energy efficiency, as well as to compare this method of heat transfer with other current ones, such as water cooling, for example. Based on the results of our research and based on the objectives set, we made the following conclusions presented on the slide. During our research, we used the following scientific literature. Thank you for your attention.
Igor, thank you very much for your presentation. Are there any questions for Igor?
Yes, I have a question. Thank you for presentation. The experiments are really very good, but here we discuss practical projects. And could you please conclude what is the result of your project? What can be used by other people in some of their work? And the second question is about existing cooling systems. This problem is not new. And there are many different cooling systems with controllers, with control systems. So did you study existing cooling systems, and what do you propose to improve in these cooling systems based on your research?
Yeah, I see, definitely. Answering the first question, the result of the whole study, of the whole research, is that we can find the actual optimal speed, and it actually flows into this second question. Did we compare the other cooling system? Actually, not really, but the result of our experiment can improve them. Well, the problem is still relevant. It remains relevant to this day. And with the research, with the experience, with the knowledge we acquired, we can improve them and make our world less less wasted energy, I mean.
Okay. Thank you.
Yeah, my pleasure.
Any more questions?
Excuse me, could you show the slide with the results again?
Yes. This one?
No. With the list.
Conclusions, you mean?
Conclusions, yes. Conclusions.
All right, yeah.
And what do you think? the wind or water cooling system is better?
As I see it, the wind cooling system is better, but I cannot tell it right away because we didn't compare them. So this is actually, as I told you, the prospect. We are going to compare them and define which will be better for the usage.
Why do you think so?
Because water cooling system is hard to maintain compared to the cooling one.
No, by physics.
About physics.
Yes.
Well,
Why you say that air cooling system should be more effective than, for example, I don't know, water cooling system?
well, all right. In terms of physics, the as we understood, the convective method is a method with mass transfer. Well, the mass from the blowing speed from the fan, for example, will cool our body better because it's it's easier to do it for it. I mean, yes.
Okay.
Mhm. Thank you for your question. We will work on it.
Thank you.
More questions? We have 2 more minutes for this presentation. No? Okay. The next presenter is Gabriel Ramses from France.
Hello,
Hello.
I will share my screen. Hello, so I can start?
Yeah, you can start.
Very fine. Hello, my name is Gabriel Ramses. I'm a student of the scientific lab of the Virginis High School, and I will present to you the Polybike project, modeling and biking to measure the air quality. The Polybike project was born from the wish of getting information about the air quality in order to aware citizens about it. Indeed, before we start, I should remind you some important numbers, like the cities represents only 2% of the Earth's surface, while they made more than 80% of greenhouse gas emission. It's also 50% of the global population who lives in cities, and in 2050, this percentage could increase to 70. But come back to our Polybike. Everything started in 2018 when the Innovation Lab Ericsson France contacted us in order to start a partnership in the aim of developing a project about the air quality. The Polybike is a device fixed on a bike, therefore it can move through the city and measure the concentration in particulate matter. Then it sends the data to a server, which will then show to the user the pollution like red dots on a map. We also have the agreement of our city, Massy, to collect and use this data. Today, we have 4 polybikes like this one, including one which works with an electrical bike and one which is always with the biking association of our city. To achieve this project, we have 5 great steps. The first one is to determine the most suitable components for an air quality sensor. Then we need to develop a program to use them. After that, we need to search for a case to who can be purchased on a bike. Moreover, we need to share to the people the data we have. And finally, we have our test phases that are here to improve our Polybike. At the beginning, we wanted to use microbit card due to the fact that we usually use it for our projects, but in it, we must use the shield with it, so it took a lot of space. So consequently, we have changed it for an Arduino Nano. Now the sensor. The first time we wanted to use NOx sensor. NOx means nitrogen oxide, gases with direct effect on health, but it needs time to warm up and the data are quite hard to use. So we have changed for a dust sensor that measures the particles between 0.1 micrometers and 30 micrometers. Then we have the LTE and GPS antennas that are required to send the data and get the GPS localization. And here we can see our final secret. We can observe that we also have a battery, of course, to power the circuits, and a SIM module to send the data. Now we have all the components. We need to develop a program to use them. The Arduino program had changed a lot, but today it's what it looks like. We first define libraries, pins, and variables. Then we have the setup function that simply starts the circuit. After that, the most important part is the loop, where we get the GPS localization. We measure the pollution of particles over 1 micrometers and 2.5 micrometers. And we convert the data due to the fact that the sensor does not use a classic unit of concentration, and we must convert the data into particle per million, ppm. And finally, we send the data to the server at the end of the code. Now we can measure the pollution. We need to put our components on a bike. At the beginning, the case were just a box that contains the components, and it was not really aesthetic. So we have brought another design with the shape of a cloud that reminds the pollution topic. But as you can see, it's really big and it's quite impossible to put it on a bike. Therefore, after much research, we have developed the current case that keeps the shape of a cloud, but can be easily put on a bike. Now we are able to get the information about the pollution in the streets. We need to inform people about that. We are currently using dots on a map. The colored dots, the color of the dots are fixed between green and red, according to the concentration in particulate matter and the air per use scale. It's also important to know that a polybike sends the data corresponding to a dot every 30 seconds. But we still have a problem is that the background map is supported by Google Map, and we need to pay for it if we don't only use that on a personal purpose. Therefore, we have changed for an open source map, which is called OpenStreetMap. With our 4 polybikes, we have succeeded to get a lot of data. Today is more than 50,000 lines of data that corresponding to more than 2,500 kilometers on bikes. And this test, we have done many tests. We have done many tests, such as the Kolmogorov-Smirnov test that allow us to show that the orientation of the polybike does not matter. We are also able to compare our data, such as after, before, or during the lockdown, or according to the weather. But moreover, the tests allow us to do improvements, such as adding a condenser or pushing away the antennas. Now, our next objective is to increase the number of polybikes in order to cover the whole city of Massy. But if we have a lot of polybikes, that could be a real with too many dots. Therefore, we need to refresh the map. But the question still is, what is the best delay to refresh the map? So thus, we have built a Python code that modeling the movement of 100 polybikes in the city of Massy. And this program had shown that the best delay to refresh the map is 15 minutes. But we also observed that the correct dots on the map weren't really practical. So we have thought about a way to give directly to the user the best itineraries in terms of pollution and distance. To do so, we have first represent the city by an Excel table, with each cell representing a street with a pollution score. Here we have put 1, 2, 3, but it could be 1, 5, 9, but we need to fix it. After that, we have thought about different itineraries, and we have shown the best, we have thought about the best, depending on the cost, which is the sum of the pollution score of each street traveled. But we need differently to have a code if we wanted to use that instead of dots. Consequently, we have built a Python code that uses the Dijkstra algorithm, with a matrix. We recover the matrix from OpenStreetMap, and we add the pollution in our calculation with the previous works, and we can give to the user the best itineraries. All in all, we have succeeded to build a working device that can measure the air quality in the cities and aware people about the best itineraries to achieve their travel. Now we want to find someone in the Paris-Saclay cluster or maybe a startup company that could take care of the industrialization and distribution of the polybike. And we hope to see one day in our cities a lot of polybikes. I want to thank you for listening to me.
Thank you, Gabriel, for your presentation. Are there any questions for Gabriel?
Thank you, Gabriel, for your presentation. I have a question for you. Have you compared your quality of the gas and different emission detection to the other devices that measure the quality of the air?
I don't understand. Can you repeat, please?
Have you compared your device with other devices that measure the air quality?
I understand. The problem is that our device is moved through the cities, while the other device, like the EPARIF one, just keep at the state place and measure the pollution at the specific areas, and we can't compare to other device.
But actually, you can move your bicycle to that place, measure the air quality there, and compare the results.
Yeah, I understand, but we just able to get data in the city of Massy, and the Paris is just at the Paris city, and we just don't have the idea of getting to Paris and comparing the data.
Yeah, thank you.
More questions for Gabriel?
I've got a couple of questions, Gabriel. Thank you for this work and the research. A couple of questions. Do you think your device need calibration with respect of the special medical devices, or it could be enough to have a relative data around the city?
The problem of one polybike is that it measures only the particulate matter, while the other device can measure a lot of other characteristics like I don't know, NOx or other things. But the advantage of a polybike is that it can move through the city and measure, as I said before, areas where the other can't measure. So I think the best way is to do the both way, and just mix the data. But it's still very really complicated to use all the data and put it on our algorithm. So I think the actual way is to just keep our data.
The second question is the pollution have very different structure. I mean, for example, carbon dioxide couldn't be obtained by your device. It all depends on sensors that you use. Do you think that this device could be pluggable for using different type of sensors?
Yeah, it's not a problem. That just we need to put it on the box, and it can be easily added on our algorithm. It just we just need to add a function. So I think it's not a problem. The really problem is the actual problem is that we need to find a sensor that can be easily traveled and do not need a warming time or something like that.
And the last question, do you transfer gathered information online, or you keep it and gather finally in the final position? And why you choose gathering and or distributing online?
What do you mean by lane?
Online. I mean,
right.
yes, transferring online or keeping and reading.
Yeah, we wanted to inform a large people, a huge amount of people. Therefore, I think the best way is to put the data online and can be easily accessible. The people can access it easily.
Okay, thank you.
More questions?
Hello,
Hello.
Gabriel. I have a question. Before I should tell that this is a very interesting project.
Thank you.
I have a question about what is the frequency between of measurements between the points.
I said that the Polyback sends the data corresponding to dots every 30 seconds.
Every 40 seconds. Okay. And do you have any problems with your power supply device, and how do you plan to resolve it? For example, for what time is of powering on of your device now, and how do you plan to maybe to reconstruct it or something else?
Right. The power time of a Polyback is around 2 hours. We also want to we can reduce the price of our Polyback. Today it's around 70 euros to build, and to do so we can change the components by a printed cardboard or something like that.
Maybe you can resolve it with using the electrobikes.
Yes, we
connecting
have
with the
already
system.
one with work with the electrical bikes, and therefore we do not have a battery on it.
Okay, thank you very much.
Gabriel, thank you very much for your presentation.
Thank you.
Let's move to the next participant.
Goodbye.
Bye. It is participant from Switzerland, Max Sheldash. Max, it's your time.
Great, thank you very much. I will share my screen with you in a second. Where is it there? Okay. All right. Great. So yeah, welcome to my presentation of my project about developing a rotor with optimized aerodynamics to propel a quadcopter. The basic research question that I prompted to ask myself was, what factors effectively influence the aerodynamic properties of a rotor, and how could I use them to produce an aerodynamically efficient rotor? And to come to the answer to that question, I based my research process upon the laws of the propeller theory by Beetz and Schmitz. And that theory contains a fundamental idea which states that an ideal rotor has a homogeneous distribution of the lift force acting upon it. Well, why is that so important? Let's look into the lift equation a bit more in detail. So as you can see here, the lift force is dependent upon the so-called effective flow velocity W. And on the right-hand diagram, you can see that that effective flow velocity varies greatly from the blade root to the blade tip, where due to the high circumferential speeds, the effective flow velocity is a lot higher. And the result of that is that the lift force at the blade tip is a lot higher than at the blade root. Generally speaking, that means that we have an uneven distribution of the lift force upon the rotor blade. However, looking again at the lift equation, we see that there are two other parameters that we could potentially vary, and that's the lift coefficient CL and the lift effective area A. So by varying them, I was able to approximate a more even distribution of the lift force. And the first step of that was to choose suited airfoils, because by varying the airfoils, you vary the lift coefficients. So that means that using different airfoils for different parts of the rotors enables us to achieve a more homogeneous distribution of the lift force upon a rotor blade. I used 3 different airfoils in total that I extracted from a public database called airfoils.de, and then I exported their airfoil coordinates into Excel in the next step, where I modified them using the parameter called airfoil depth L. And that airfoil depth is used to stretch airfoils relatively to their distance from the blade root. And as you can see, it is a part of the lift effective area A. So by stretching them more at the blade root than at the blade tip, there is more lift effective area at the blade root, and thus again, we have gained a more even distribution of the lift force upon the rotor blade. And the third step was then in also modifying the airfoil coordinates using the so-called construction angle alpha K. And that construction angle is used to align the airfoils parallel to the air inflow direction, because again, that varies heavily from the blade tip, where it's almost horizontally, to the blade root, where it's almost vertically. And aligning them parallel to the air inflow direction means that there's less drag effective area, and reducing drag gains aerodynamic advantages. And the construction angle alpha K is made up by 2 other angles, the angle of attack alpha A and the angle of incidence alpha E, but due to time reasons, I won't go into detail about those 2 other angles in this presentation. So I ended up with these columns of numbers, and each column represents 1 modified airfoil. And then I again exported them into the CAD software SolidWorks, where I made a 3D model out of them using some sketch functions, as you can see in the middle picture. And after that, for a second prototype that I constructed, I also additionally attached winglets to the blade tips of the rotor blades. But I come to the reason for that later on. And after that, I then exported the 3D model into a 3D printing process as a 3D printing software using a PolyJet printing technique, and removed the supporting structures of the printing 3D printer, attached the rotors to the quadcopter connection pieces, and then they were ready for some test flights. So I constructed this test rig that you can see on the upper hand right corner. It's a very small picture, I know, but the basic idea of that test rig is that there is the rotor with the motor that powers it, and that is mounted upon a metal beam which stands on a scale with one of its feet. So when the rotor starts turning, the scale will show less weight, and from that difference in weight, I was able to derive the lift force that was generated by the rotors. So looking at the results on the right-hand side, you can see that the first prototype, which I named Design 1, the gray line, hits the red line at about 6,400 rotations per minute. And the red line indicates the amount of lift force necessary for the quadcopter, namely my quadcopter from the Chinese company DJI, to take off. And Design 2, the second prototype, came along with a major improvement of about 700 rotations per minute. You can see that that's the blue line. And however, comparing it to the DJI standard rotors, namely the rotors of the Chinese quadcopter manufacturing company DJI, you still see that that green line outperforms the blue line of my second prototype. So that was the reason why I then, and I'll come back to this, why I then attached winglets to that Design 2. And the basic idea of winglets is that you have a high pressure region under the rotor blade, a low pressure region above the rotor blade, and Thus, you will have a cross current when the rotor turns. You will have a cross current occurring around the blade's tip, and those cross currents, they produce little whirls, and those generate drag. So putting a barrier on the blade tip in form of winglets reduces drag force. And that was the basic idea with the first two designs. And the third design, I call them the slope winglets. My thought behind that was that due to the, as I called it, the slope form, the round form of the winglets, they do not only prevent drag force, but they produce additional lift force because they accelerate air towards the ground due to the law of conservation of momentum. That means that there is a counter momentum, which is nothing less than lift force. So A, it reduces drag, B, it generates a bit of additional lift force. And you can see the result of those three winglets on the left-hand side here. First of all, as anticipated, the oval and the circular winglets, they don't really lead to any major improvement of design 2 without winglets. However, the slope winglets, they perform about 200 rotations per minute better than the other two forms. And comparing design 2 with slope winglets to the DJI standard rotors, you can actually see that for the range of rotational rates shown in this diagram, they outperform them by a bit. So going into these results in a bit more detailed manner, and the significant improvement from design 1 to design 2 that you can see here is mainly because of differences made in the construction process. For the airfoil selection, for example, I created a little criteria catalog for design 2 so that I didn't just choose the airfoils randomly or by heart, but that I actually had a sort of a tactic for which parts of the rotors would I choose and what kind of airfoils. And then the following steps, namely the calculations, I of course learned from the experiences from design 1, and those became more precise as I constructed design 2. And then I also made some minor deviations in SolidWorks, mainly with the connection pieces for the quadcopter. So those are the major reasons for the occurrence of that improvement. And as I already explained, the success of the slope winglets is mainly due to its form factor, and the thoughts that I made in theory proved valid in certain to the certain extent. So coming back to the original research question, we now know that of primary importance to the aerodynamic performance of a rotor is the selection process of the airfoils, the calculation of the two parameters, namely the construction angle and the airfoil depth, and the design of winglets. And using those points, I developed a total of 5 different rotor prototypes over a period of about 1 year. And as you saw before, one of these prototypes, namely design 2 with slope winglets, ultimately succeeded in outperforming the design of the quadcopter company DJI in terms of its aerodynamic performance, namely the ratio of the lift force to the rotational rate. So thank you very much for your attention. And if there are any questions that have popped up, I'm very, very happy to answer them.
Thank you very much. Next, is there any question?
Welcome.
Thank you for the good work. And I have one question. Why you choose as a criterion for aerodynamic performance the rotation rates of the rotors without the power and without any other characteristics? Why you make this choosing?
Okay, yeah, so we used the lift force in relation to the rotational rates, and we also measured voltage and the current through the black box that you see in the upper corner of the little photo of the test rig. That malfunctioned a bit, however, and later on I then determined these characteristics with a test flight, and that was more precise. But generally speaking, I used the lift force in comparison to the rotational rates of the rotors or of the motor, however, because I made the assumption that that was the most precise, not precise, but the best way to compare the rotors to each other.
But the resistance force depend on the velocity. And you find the force which can take up your mass. How you used your data for understanding which better, which not better.
Yeah,
and,
so
it may be criterion by 1 watt, 1 kilogram by one another.
Yeah, so it may be hard to exactly determine derived with this data that we got how much drag, how much resistance, and how much lift force do they actually generate. But the force that you see here is like, I would say, the net force, because when looking upon that weight difference on the scale, that already implies the changes through the drag force, and that is basically like the net force. So yeah, it is difficult to determine which how much drag and how much lift force there is exactly, but that is sort of the difference of those two. That's the net force at the end, and we would need other testing methods to determine those two forces separately. Yeah, I mean, I would have to think about that in more detail.
Okay, you use as a qualitative comparison, yes?
Yes, that's right.
Thank you.
Thank you.
Any more questions?
Do you measure power consumption in this experiment? Current value depending on rotation at the same in different conditions.
Yeah, so we try to measure the power consumption on this test rig. However, the device malfunctioned and it showed a very high sort of peaks and lows, so we couldn't really use that data. And the results of the test rig that we made here were that they were, in terms of electrodynamic performance, they were about equal. And I then, as I mentioned, made another test flight where I was able to determine the power consumption. And then when measuring the weight of the quadcopter, I was also, of course, able to then derive the lift force that those rotors produced. And I put those in comparison to each other. And the results were that the rotors of the Mavic Pro consume a bit less energy per, I think it's about 5% per rotation. And my thought on that was that that is due to the low glide ratios of the rotors that I built, and the airfoils used, and that's a better explanation, because that glide ratio basically describes the relation between the lift coefficient and the drag coefficient. And I didn't know that something like that glide ratio exists. As I calculated those methods, I just found that out recently. And apparently for low glide ratios, which most of my profiles have, there is more power needed to for one rotation of the rotor, producing the same amount of thrust / lift force.
So am I right that rotation rate fluctuated less than currency?
May you? I didn't exactly get the question.
You said that it was difficult to measure power consumption because of fluctuation of the value, but rotation rate was stable at this regard.
Yeah,
these conditions.
Yeah, it was due to the measurement devices that we use, because for determining the rotational rate, I used in German we would say stroboscope, like a device with a light beam flashing very fast so that you can determine the rotational rate. And that, of course, was quite constant throughout the experiments. You can see that sometimes it had little fluctuations, for example, those exponential lines, when they have a little point that settles above the exponential line. But the reason why the electrodynamic properties and the power consumption had such a high fluctuation was that the device obviously malfunctioned, and that's not due to the properties of the rotor blades, but that was due to the device that we used. That maybe it was an old or broken device, so I then, as I said, had to repeat those measurements with test flight.
Okay, thank you.
Thank you very much, Max.
Thank you.
The next team.
No, okay, before our presentation, Rotem, this is before our presentation, so don't count the time, okay, Rotem?
One moment before we begin, today is the Israeli Memorial Day for fallen soldiers and victims of terrorism, and our hearts go out to all the families that suffered these consequences. Now let's begin. Yes.
So hello, we are Litchi and we present to you Drive Alive. And in our presentation, we're going to talk about our solution for drunk driving, what we built, and the advanced research we did with the University of Tel Aviv.
We mute.
Sorry, I didn't notice I'm on mute. So this is Drive Alive by Litchi, and in our presentation, we're going to talk about our solution for drunk driving, what we built, and the advanced research we did as well. But before, the problem. You see, on average, 1% worldwide is killed every 30 seconds because of a DUI, driving under the influence of alcohol. It means that in only 1 year, more than 1 million people die and over 150 million get injured as a result of DUIs. Now, driving after drinking alcohol is the most prevalent cause of death and injury on the roads. Any amount of alcohol in the bloodstream can impact one's driving ability. Alcohol impairs many of the functions necessary for safe driving, such as decreasing motor skills and reducing reaction time. Actually, in Russia, the annual mortality rate from DUIs is the highest one in Europe, with around 300 deaths per million capita in a year, which are approximately 43,000 people. Today, the most effective device designed to prevent drunk driving is breathalyzer, which are non-sterile and easy to cheat solution. Drive Alive by Litchi is a revolutionary way to prevent DUIs.
What is the product exactly? Our product is a fingerprint-based lock for the car's engine and immobilizer. The lock prevents the car from being started at all if the driver is drunk. The device consists of two main sensors, a spectroscopic sensor and a fingerprint sensor. The spectroscopic sensor enables determination in a non-invasive way of whether a driver is drunk or not. If they are, the immobilizer locks the engine and prevents them from driving, while displaying a small amount of time on the screen. On a small screen, the estimated amount of time which the driver will be sober again. Okay. The device is based on infrared light, so it's very efficient and extremely accurate. By the way, we found out that the accuracy level is around 99.99%, as we're going to show later. The fingerprint sensor, which identifies the driver's identity and protects it from theft, it also adds to the overall amount of security the product adds to the car. Our product works as follows. The driver enters the car and places their finger on the immobilizer. The system checks if the fingerprint is allowed. If not, the car's engine locks. If it is allowed, the immobilizer checks the driver's alcohol level and locks the engine in case the levels are above the limit. In such cases, the screen shows the estimated time that the driver has to drive. If the driver is sober, then you can drive safely. The estimated price is about $80 per unit in mass production.
Now let's talk about the scientific background behind our project, which is spectroscopy, the study of light waves. It means measuring intensity of light in different frequencies and wavelengths. You can see the spectrum of light here, and we'll focus on near infrared light, which ranges from around 750 to 2500 nanometers. It is very similar in properties to visible light, and it observes absorbance relative to other materials. For example, distilled water, which we used in our research to be shown later. We have seen in our research that ethanol, which is the alcohol in alcoholic beverages, absorbs near infrared light optimally and around 1180 to 1190 nanometers. Here you can see the full graph from our research. You can see the peak here, and here's a close-up where you can see the exact level of maximum absorbance. We have also checked the feasibility of such a product, and we've seen the following. Fingerprinting immobilizers for the car already exists today in the market. And for the spectroscopic sensor, Samsung uses very similar technology in smartphones to check blood oxygen levels, of course, in different wavelengths. Therefore, if you combine those two technologies into one product, we can create a very safe and secure ecosystem.
Okay, so now I'll talk with you about our prototype we built. To prove our product's concept, we've developed a working prototype that determines if someone is drunk or not. We also conducted experiments in lab scenarios in the Tel Aviv University, which we will talk about later. We connected the spectrometer to an infrared light source, as you can see here, in a specific length, and wrote an algorithm that will determine if someone is drunk or not only by looking at the return spectrum. We funded it using crowdfunding and bought it all the parts together for $500. We made it all and run with the help of soldiers in the unit 8200, the Israeli Defense Forces SIGINT unit, and run it through primary tests with code we wrote in Python ourselves. So this is the prototype. And this is an image from a side view. At first, I put my finger inside the desired area and the infrared light goes through it. The light gets reflected by the mirror. Then it goes through the linear light diffraction plane. Which splits the light into its spectrum. Then the camera observes the spectrum and sends it to the computer for the algorithm to process it. Now I'll demonstrate you the prototype in action. I'll put my finger inside the prototype and plot the return spectrum. So this is the black line. Now I'll put some alcohol on my finger and plot the data again. Okay, so as you can see, there is a big difference between the two graphs. The red one is with the alcohol and the black line is without. Okay, so it's important to say that the alcohol gel, the amount of alcohol in the alcohol gel is much higher than the one in alcoholic drink, so we can definitely separate it from a real ethanol in the blood. Our algorithm works like this. After we get the image from the camera spectrometer, the program is adjusted to find the diffraction of the infrared light. The code knows automatically to lock on it. After we get the cropping of the light diffraction, We can slice it into parts which represent different wavelengths of the infrared light. The x-axis represents the index of the slice from left to right, and not the wavelength, but those are dependent on each other. The y-axis is the slice's average brightness, representing its light intensity. As you can see in the next slide.
Okay, so now let's talk about our research process.
The graph, just look, this is the graph. Okay.
Okay, so after building our own prototype and proving our product's technology works, we wanted to take it to a new level and get an academic approval. We reached out to the Faculty of Engineering in Tel Aviv University for more accurate and deeper research. After raising $5,000, we bought the professional tools we needed, which includes near-infrared spectrometer, inline filter mount, broadband 60 to 2600 nanometers, light source, and optic fibers. Then we set up the workspace in our fully equipped lab in the university and started our research with the Faculty of Electrical Engineering and the escort of Nadav Arbel, MSc, and Professor Avishai Eyal. For the first round of experiments, we took measurements with different amounts of ethanol percentage and distilled water. We started with 96% ethanol and split it like this. The first test was 96%, then 48, then 24, and etc. until 6. And of course, the reference test of pure distilled water. Every data point is an average of 50 measurements, measured automatically using the software we use, Oceanar. After conducting two sessions of tests, we came up with very promising results that ratified our theory. First of all, we can clearly see how the ethanol affects the absorbance of the return spectrum and that the gap between each concentration intensifies with each lap, what forms an exponential growth of light absorbance. In addition, we found that in the vast scale of infrared wavelengths, the best for the ethanol's light absorbance is 1180 to 1190 nanometers, like we found in the previous test. Now, with the use of the more accurate tools, we were finally able to get starting on demo of functioning algorithm that will be used in the prototype of the immobilizer. Here you can see the results.
This is the results from the more accurate experiment with the University of Tel Aviv and the engineering faculty. Now, let's talk about the future. You see, we want to actualizing this idea. So after we submit our research in cooperation with the Tel Aviv University, we plan to move forward on making a legislated patent. After that, with the financial help from the Israeli Ministry of Education, we will work together with a private development company for product design and also create our first complete device. And from there, the sky is the limit for us. Thank you very much. And remember, it's not our product, it's about your life.
It's your life.
Thank you very much for so much interesting project.
Okay, and we will be happy to answer any question you have. And sorry for the bad picture. It was in the middle of a very long day at the university in the lab. So sorry.
Thank you very much. Okay. Any questions?
Okay, I have a question. Did you study if there a chance that this device will block a car by some other reason? For example, driver took some meds or used sanitizer or some other reason?
Okay, so for other materials, we've seen that they don't interact with infrared light in the same way, and only alcohols interact with it in the way that we have shown here. For hand sanitizer, which has a very high percentage of the alcohol, we actually said this, it will detect that it's a very high percentage and know to calculate if the driver is actually drunk or if they put hand sanitizer through the algorithm.
Did you make a patent application?
Not yet. We're discussing with lawyers our options in that matter.
Because,
our main problem is that we don't have money because we're kids. So it's all about money in this world.
It's not to make an application. It's not much money. Yes, further you will require it, but at the same time, I see there is a product on the market, AlcoSense True Touch biometric alcohol tester, produced in Britain. There is a site alcosense.co.uk. They provided the same tester for alcohol. Maybe they don't have a patent, but did you provide the patent search in this regard?
Can you repeat on your last sentence?
We
did. Did you do the patent search for your research? It's absolutely free in patent database.
We searched a couple of times for other products.
Yeah, we've used to.
We found our product and its platform that connects straight to the car's engine is unique, as we found currently. We will do multiple more searches, but to the current search that we did, I can see I opened the link that you sent. The AlcoSense is it does the same test, but it doesn't connect to the engine the same way, and it doesn't secure the car in the same way, and it's big. It costs.
They also don't have a patent.
Not right now.
And I'll just say that we actually spoke with several top lawyers in Israel for patents. This is we can go for patent. It just costs money that we're trying to raise right now. Now, two things. The first one, most patents, technological patents, isn't about new technology. It's about combining a technology with other one in a unique form or a unique platform that will allow you to make a new product. Those are most patents. This is what we were told about from the lawyer. Now, in Israel, we're the champions of the Israeli Ministry of Education for entrepreneurship and startups in youth, and because of that, we're entitled. And for that, we're entitled for financial backup from the Ministry of Education. It just held back because of the coronavirus, but we're looking forward to get the help we needed from them as we were promised, and we'll go forward ahead as soon as we will get it with the patent and the first actual device.
Did we answer your question?
And just one more thing regarding the application, which Dimitri earlier mentioned. It's not about the money of making the application, because we started making the application itself, but there is law issues with it because the application should connect to the device and hold the fingerprints of the users, like Pointer, if you're familiar. And so there's not a lot, but we should use more financial backup and lawyering backup. So, but we did make the necessary process to develop it.
Thank you.
Is there any more questions?
Yes. Hello, guys.
Yes. Hello.
I have a question. In which way your device blocking the car's engine? In which way?
You asking about the way that it connects to the engine? It locks. It connects to the engine the same way as a regular immobilizer that you put in the code. It connects to the car the same way.
But do you know that most of cars has some kind of very high level of security of these immobilizers?
We plan to work with car companies and car licenses. We plan to work.
So
we have. Okay. Yes.
So do you plan in there asking for API? API.
Excuse me?
API. Interface, program interface.
Oh,
I'm
API.
planning for asking. Yes, API. Yeah.
Yeah. We're planning to connect with a car company that will combine our product inside their cars.
Yes, we have several. We have a very diverse market. You see, first of all, car rental companies, insurance companies, transportations companies, responsible drivers that want to buy the product for themselves. Now, you might think that I'll say it like this: you might think it's not a new idea, but actually, if you look up, obviously the technology of spectroscopy, this field in physics, isn't new. Because we didn't want to invent physics. We didn't came. This is not this is why we didn't enter the physics competition. We wanted to take this spectroscopy and combine it with something new. And if you will look, there is not a single immobilizer that connects to the engine with fingerprints in the world. There isn't one.
Okay, thank you very much.
I just wanted to say, if I'm allowed, that our unique product is something that can be encountered with every market, and that's because at first we wanted to connect it to the car directly, but it's more expensive. It has a lot of more issues, and the accuracy is falling down because you can't use it on different users. But the idea in an immobilizer, it can connect to each car in the world, regardless of the system in the car. And we actually researched about it with several car companies, and we used the help of Toyota in Israel to see the systems in each car, and we came up with the idea of immobilizer is the best for each system. It's universal, basically.
Are there any more questions?
By the way, I'll just say that just for you to see the demand for the product, the $5,000 worth of equipment that we bought ourselves is from a small investment from Toyota Israel, just for you to know.
Yes, thank you guys for your presentation. I actually have questions. Would you would you consider to do some additional justification that the person is drunk? I think it would be a great idea to justify this by video or by any other methods.
We created a test in which of our previous prototype, and we tested a drunk person, and we checked if it works, and we checked the specific unique wavelength. It works as well. We didn't film it, but we did this.
I mean, we can also consider other ways to detect drunkenness inside the whole package.
Yeah, so it would be a great idea, because now, as the first jury said, that there are a lot of methods to, go ahead of your system. So, for example, when I took some alcohol, it's just as it was in your demonstration, when I took some alcohol and split it on my fingers. Do you understand what I mean? So
yeah, we consider
the person is not drunk, but your system.
Okay, we just want to say, because apparently it might be a misunderstanding, but every wavelength of every material is unique, and you consume different materials. The wavelengths are different, and it's programmable. And in terms of the alcohol gel, though, it has such an extreme amount of it on the finger that we can program the machine to ignore it.
Software, yeah.
I think you didn't get my question. I mean, and my recommendation. It's more recommendation than a question. So when I put my fingers in alcohol and then came to a device, it would say that I'm drunk, but I'm not drunk because it's just some spills of the alcohol on the fingers. So I would recommend you to do some additional justification of that if the person is drunk or not. By the video, by the blood test.
We'll consider your recommendation.
That was actually part of the software of the plan. We considered this option.
Thank you.
Okay, guys, thank you very much for your great project. The time is up and we have to move on to the next project from Turkey. Thank you very much.
Okay, bye-bye. Thank you.
Thank you very much.
Hi. Can I start?
Yeah, you can start.
My teammate isn't here because of health problem. I will show our video presentation to you. Can I show you?
Sure, you can see.
Okay. Hi, my name is Muslim. Hi, my name is Maya Karabu, and our project name is Bright Floor for Our Elders Students, Life on Our Future, Isaac. Today, the growing elderly population and the elderly dependency ratios are taken into account to take part in the daily lives of physically moving in important elements. For a self-sufficient elderly individual is an important issue. The importance of this study is to support the freedom of movement of elderly individuals with the practical use of developing technology. The study was limited to reduce the number of accidents that elderly people experience at home or nursing homes due to falling or sleeping in the dark. Research question. First research question is what kind of precautions can be used to reduce indoor accidents caused by elderly people due to sleep or stuck in the dark? Second question is what kind of technology can be determined precautions being modeled in practice? Third question is in what kind of product can the developed model find in terms of use? Among the internal accidents experienced by the elderly, use that occur due to sleeping or stuck in the dark can be reduced with bright floors. Lamps triggered by piezoelectric sensors are designed to light when the floor is set. The LED circuit that lights up with the piezoelectric sensor program with the Arduino Uno card was established. In order the model to determine precautions, a sample model in which the entire floor contains piezoelectric sensors was designed when 4 piezoelectric sensors on which pressure is applied are connected in series with 2 LEDs in front of the light on for 5 seconds. Thus, the floor will be bright until next row. The station continues as it moves on the ground. In this way, an environment that lights up that separately instead of constantly keeps lighting it inside. For the system design to be placed in a building under construction, piezoelectric sensors are positioned under the floor, covering consisting of strips made of foldable model material such as parquet or tile. For the portable application developed for use in existing buildings, the bright floor is covered with a parquet-like material design. The station that was considered as the first subproblem was that precaution could be used in those households in the dark of the elderly. Regarding this, the researchers designed a model that contains lamps that turn on when pressed on the floor as an alternative to the lamps on the wall with an electric switch. It is known that there are motion sensors in the most of the mobility. The difference of the developed system from motion sensors is that it can guide more effectively because it is laid on the target floor and it is not turned by the slight movement of other individuals or pets living in the phone. In this direction, it was decided that the sensor that can be used on the ground would be compression-sensitive piezoelectric material, and the situation was designed with the piezoelectric. After getting the result, the second sub-problem, how the floor can be designed with this technology as a whole, has been started, demanding that the developed system can be used not only on the room floor of newly built buildings, but also in every existing house, has created the third sub-problem of the study. In this direction, the model created with the material that can be considered as parquet is also modeled with the material that can be considered as a carpet. The sensor can be placed between two parts of carpet and smoothly record through. As piezoelectric technology becomes widespread day by day, 51 millimeter piezoelectric sensor that can be displayed for 2.78 channels, including one in January 2020, will soon become more economical. In this case, the products proposed in this study will be more accessible. I examined the model design planned for all elements, who are the most important resource, shielding lights on or features, can be used in hospitals and living spaces of disabled individuals as well as homes and nursing homes. While every age group is distributed by the night lamps that are constantly on all night until their way is dark with items in their phones. Children around the age of 3 whose night sleep is often interrupted can easily reach their mother's rooms when they wake up. Since the piezoelectric sensor that produces electricity as a result of the pressure acting on them could not produce enough electricity, the sensors were used as triggers in the circuit. With the development technology, it will be possible to produce electricity without a power supply with more efficient piezoelectric, which will be more accessible. Thus, it can be turned into a design that produces its own energy by heating and idling. Thank you for listening.
Sorry, the background I couldn't set that day.
Is it finished?
I'll show a video. Wait a sec. It's finished. Thank you.
Thank you very much. Are there any questions?
Yes, I have. Girls, thank you very much for your presentation. And my question is, do you discuss this project with your maybe parents or grandmothers, grandfathers? What they say about this idea?
Yes, I discussed that. I can't explain because my language not enough to explain to you right now. because I'm so excited right now. I discuss my teammates' grandparents, and they love us. I can't, sorry.
They said, okay, it's a very good idea, yes?
Yes.
Okay, thank you.
More questions to Celine? Great. Do you have a question, Dimitri?
You connected your sensor to the computer. How did you do this?
Arduino Uno, that's the program. I can show, but I'll try. My teammates' grandparents love this idea because they had a problem with this situation before the grandparents' house.
Did you make the electronic connection to the computer by yourself?
Yes, we together made this.
From what? What do you use for this?
A program Mblock. Program's name is Mblock. We used.
Okay, thank you.
Okay, Celine, thank you very much for your presentation. Let's move on to the next project. It's project from Russia, Nikita Yelistratov.
Hello.
Hello.
Can you hear me?
Yes, we can hear you. Celine, please switch off your presentation.
All right, all right. Wait a second, please. Can you see it?
Yes, we can see it.
All right, full screen.
Yeah.
All right. May I start?
Yes, we can start.
All right. Well, my name is Nikita. I'm from Surgut, Russia, and I'm glad to introduce you my work on the theme exploring the use of electromagnetic induction to control the luminance of LEDs. So I like music, and that is why I know the principle of working of electric guitar. So I came up with an idea. What if while playing we can control the luminance of the concert hall, just to make light shows while playing, or even charge the phone. So object of the study is the process of increasing the luminance of light emitting diodes. The subject of the study is possibility of application of electromagnetic induction phenomenon to increase luminance of light emitting diodes. The aim of our study is to study the phenomenon of electromagnetic induction and the possibility to apply it for increasing brightness of light emitting diodes. Tasks you can see on the slide. Also, research methods you can see on the slide too, just a little bit of formality. Well, as you understood, the idea is the working principle of the electric guitar. This idea is based on two basic principles. The first one is that you need to catch the signal. The second one is that you need to strengthen that signal. Pickup is the device that used for catching the signal. There are two types of magnetic pickups, singles and humbuckers. If you wish, I'll tell you later about their constructional differences, but in general, pickup, it is a coil with the magnet inside it. So when the metal string fluctuates in the magnet flux, induction current appears and it goes to amplifier. Amplifier, it is a device that is used for strengthening the signal. All right. After amplifier, the signal goes to the speakers and we hear the characteristic sound of electric guitar. As amplifier, we used silicon transistor NPN. Now I'll show you video where you can see how the guitar works just when it is connected to speakers. And sorry in advance because I have no ear for music. I hope you have heard it. Well, but then we thought, what if instead of speakers, we put light emitting diodes in the output? So that's what we have. You will see that at the beginning of the experiment, diodes are shining, but when we start playing, they shine brighter. Just watch, you'll understand. All right. It is so because diodes, light emitting diode, it's a device that works on the average amperage that goes through it. So at the beginning of the experiment, amperage is about 200 milliamperes. So the luminous flux is a bit less than 300 lumens. But when we start playing, amperage increases. That is why luminous flux increases too, and it becomes more than 300 lumens. All right, now let's see, let's find out how the all parts work together. We have a 9-volt source, 9-volt battery. Current goes from plus to this node. Here it splits into two parts. One part goes here to the base of the transistor, and transistor is in semi-open state. Then other part goes through the diodes to the minus. That is why diodes are shining at the beginning. But then we start playing the guitar. Here the string above the magnet, it fluctuates and changes magnetic field. That is why induction current appears. It is alternating, so it goes through the capacitor to the base of transistor. That is why transistor opens more. And at this time, amperage on the diodes increases. That is why while playing, they start shining brighter. All right, here is just Charge Electronics. Here you can see self-made pickup in blue tape. Here the magnet, all right, and on the second photo there are just wires and how it is all connected. Well, here you can see the design and technology. I just want to say that everyone can make this thing at home. There is nothing hard, but the only problem is to find the body for the guitar, because you know, we've chosen the shovel, but this shovel is used for finding mines, so it's almost impossible to drill holes in it. All right, then we decided to make an experiment. We tried to find other parameters that on which depends the brightness of LEDs. So here you can see oscillogram for the thickest string. This is the oscillogram for the thinnest string. So you can see that thickest string has, here's thickest string. It has greater amplitude and greater period of oscillation. That means that it changes magnetic flux more. Therefore, more induction current appears, and that is why a transistor opens more, and hence diodes shine brighter. So the result, the conclusion of this experiment is that the thicker string is, the brighter diodes are. That's simple. Well, and the results, we have confirmed our hypothesis. We have studied the phenomenon of electromagnetic induction, the possibility to apply it for increasing brightness of light-emitting diodes. Thank you for your attention. Now I'm glad to have the conversation with you, ask your questions. I'll try to do my best.
Thank you, Nikita. Any questions to Nikita?
Hello, Nikita. Thank you very much for a very interesting project on investigation of electromagnetic induction. I have a comment. Perhaps you can think about what to do with this light next, as you've done with the sound. How can you make the light control something else? For example, if you use it as a input to a system to control, for example, lighting system, or perhaps an effect. Do you have an idea of how you can use this light further on your chain?
To be honest, I haven't understood you a bit. What do you mean by using this light for making, for controlling the lights?
So you are generating light from playing your spade guitar, right?
That's not correct, because I just increase their brightness by playing.
Sure. I'm saying you are using your LEDs to extract some of the energy and turn it into light, right? And
yes,
it's responsive to the movement of your hand. So, for example, the strength and the dynamic of the use of your hand, it being reflected in the light because it's blinking according to the strength of the movement. If you use it, for example, as an input into another system to control an effect, for example, a delay or a reverb or chorus, have you thought about this?
Oh, that's interesting. I haven't thought about this because I have no professional amplifier. Everything that you saw was made by me. So, but that's a good question. I'll try to do it in the future because I have friends with amplifiers. Also, speaking about the future, I want to, I want to put diode bridge here in the development, in the project. All right, in the product, yeah. And then I want to make this alternating current. I want to make it constant, and try to charge my phone, for example. That's it. That's my future plans.
Okay, it's a suggestion for further work because the intensity of light is directly proportional to the strength on how you play.
Yes.
You can use that as an input, for example, a sensor that can be controlled by this intensity of light to control another device in your play. It can be a lighting system or a effect system. So it's a very interesting project, and I think many musicians will appreciate how to expand the guitar playing into a more dynamic system. So well done.
Thank you. Appreciate it.
More questions? Nikita. Nikita, thank you very much for your presentation.
Thank you.
To the next project. It's team from United Kingdom. Okay, girls, you can start.
Just give us a second. Punch yourself. Can you see that?
Yeah.
Okay. So, hi, my name is Evie Williams. And I'm Lily Dimitrova. And we hope you enjoy our project. So what problem is it that we're trying to solve here? Well, lameness is a term that we use in the horse world to refer to an abnormality of gait caused by any sort of injury. And it's a problem that many horses will experience at some point in their lives. 90% of these cases are related to equine orthopedics, so originating in the foot, or most specifically the lower leg of the animal. Now, we're focused on the sport of show jumping, and the biggest cause of lameness that will affect show jumping horses directly is overuse of the superficial digital flexor tendon, or the SFT, which is the tendon that runs down the back of the horse's leg. Now, as you can see in the picture, that horse is landing the jump, and the rounded part of the horse's leg towards the bottom, otherwise known as the fetlock joint, is being pushed down to absorb the weight and the force of that jump. And that is what's stretching that superficial flexor tendon and can cause a lot of injury.
Also, this isn't normally very easily detected. So having a device would really help.
So what's our solution? So we've created smart tendon boots. These will act as a guideline for riders to help them understand how much force it is their horses are actually experiencing when jumping. The way they work is that they have technology integrated within them that's able to measure the downwards acceleration and feed this back to an app, which will have our pre-estimated or predetermined maximum accelerations, otherwise known as benchmark. And if the current acceleration that the horse is experiencing exceeds this, then the rider will be alerted to stop. This is useful because it will help prevent the rider from overworking their horses on tendons that have experienced too much force or too much stress, and allow a horse a proper period of rest. Another thing that amplifies this problem is the fact that a lot of riders do not realize when their horses go lame or are injured, because injury can be very, very small, but can build up over a certain period of time. And we can see that in the statistic below, where 60 sport and sound riding horses underwent scientific analysis, and it was found that actually 73 had gone lame, meaning that riders just cannot pick this up by eye.
So the way that this will work, it will use a MEMS accelerometer, which will constantly measure the acceleration it experiences. There will also be a microcontroller, which will be collecting the accelerometry data every millisecond, and it will find the moving average over 0.1 seconds. However, this could also be over 0.2 seconds. This is just to save storage and have a better understanding of how much force your horse is experiencing. The current value of the moving average is then sent to the HC05 Bluetooth module every second. It's then compared with the most recent maximum acceleration. And if it is larger, it's just immediately sent to the Bluetooth module so that you don't have to wait for this moving average. The Bluetooth module is also paired with a mobile app, which collects the data from the microcontroller and will alert the rider if the maximum acceleration has exceeded the predetermined benchmark value. And over here we have a schematic diagram of the prototype in partnership with De Montfort University. And we also have a video demonstration for you, so please let me know if you can't see or hear it. Oops.
Of the prototype. Hello everyone, welcome to the video demonstration of the prototype. This right here is the Arduino. This over here is the hardware. This over here is the HC05 Bluetooth module. So we're going to open the app now. At the top right there's a button that says connect. Connect to the Bluetooth module. Right, and let's say the horse would be jumping at 1.1 meters. Into 1.1. The value on the right is the calculated acceleration for which the horse can take at jumping at this height. And the 9.70 is the acceleration on Earth. And the app is ready to record movement and acceleration. So if I take this and move it, the value will change. There we go. If I go a bit more. Now as you can see, the light bulb has gone magenta, which means that the rider has been alerted that the horse has taken too much force. Thank you.
So this is obviously a prototype and simply the foundations and proof of concept. However, if we were to make a finished product, the app would work in terms of force instead of acceleration, using the simple equation force equals mass times acceleration. This is because the mass of the horse, mass of rider and tack, which is the stuff that's on the horse, may vary, and obviously the force will be greater if there's more mass. Prior to riding, the app will ask the rider to insert the following data and different factors that may affect the amount of force the horse experiences.
Adding on to what Lily has said, what you've just seen in the video is simply a prototype and the foundations or the bare bone of what we're trying to build. And so continuing to build the app, we would aspire to go for something like this. As you can see, the rider will be asked to insert their personal details, as well as the following information for data collection, processing, tracking, and further research purposes.
So the calculations used in this are from a paper, and the details are at the bottom. They used 4 different jumping heights from 1.1 meters to 1.4 meters. And we calculated and estimated more maximum values for these jumping heights using a curve of best fit. Here we have the table that we're talking about, and we're looking at the maximal vertical force, which is in newtons per kilograms, but that just equates to acceleration, so that's not a problem. And we did actually do some coding as well. On the left, we have the Arduino coding, which is written in C. And for the accelerometer part, this is how it deals with the accelerometry data, simply using 3D Pythagoras. We also have the rolling average, which can be changed, and we have the Bluetooth module, which is connected to the app using the command serial print. And on the right, we have the Android app, which is written in Java. We have the estimation equation over here, which is used to make these predetermined values. Now, how we made these predetermined values were from two different types of formulas. We interpolated and extrapolated the data to figure out the values in between it and predict the rest of the data. On column D, we have the line of best fit, and they are linear approximations. And on column E, we have the quadratic approximations. From 0.5 to 1.25, we took the linear approximations. And from 1.3 to 2, we took the quadratic ones to make a more smoother line, not as jagged, and it makes sense. So we ended up with column C, which was the curve of best fit, and that is how the graph looks like.
Okay, so just to summarize, this is simply just a summary slide to show you the events and the processes of using the product and the app. We're not going to dwell on this side, but the most important thing to take away from this is the fact that the benchmark force is predetermined and simply an estimation based on the data that you've already seen. That's because we simply don't have access, or there hasn't been enough studies done regarding horses and forces in show jumping, or there hasn't been any studies collecting accelerometry data that we could use.
The study that we did use was quite recent.
Okay, so how is this innovative and how is our product actually going to help? Well, there are a number of reasons, as you can see. Firstly, wearable technology just hasn't really made it in the equine world. Currently, there are companies and businesses trying to build it up and trying to develop it, but again, it just isn't there. And we see this as a problem because horses are just as much athletes as humans, and we think technology like this will really, really help horses and benefit a lot of equestrian athletes. Again, this is going to provide a really affordable and easily available solution to one of the biggest problems in the equestrian industry, because the components, the materials, everything that actually goes into the whole product, the actual boots, is incredibly cheap and very low cost. This can also help many equestrian governing bodies to collect data over a certain period of time and putting more competition restrictions and rules to prevent overuse. What this means is currently a very, very small pony, for example, could jump 160 or could be entered into that sort of course and jump that height. And obviously that is not good for its tendons because that horse is not built to jump that height. However, seeing this data presented to governing bodies, they'll be able to see facts rather than opinions and put in these restrictions to benefit the welfare of these animals. Again, researchers can also use this to gain a better understanding of the specific factors that contribute to injury or optimum force, i.e. if a specific breed jumping a specific height injures themselves, you'd be able to look at everything that contributed to that horse injuring itself and then further put in restrictions and rules. And this can also simply be used to better our actual product. As we've said, this isn't as accurate as we'd like it to be. Broadly speaking, it is where we'd want it to be, but it can better as time goes on and more studies are done. We did speak to a professor from University of Liverpool who was previously a vet for 5 years, who said, quote, "It would be very useful and would definitely have its place in this industry," which again just backs up the fact that this isn't a thing, this isn't there, and it definitely would be
change the game.
Yeah.
Over here, we have collaborations involving University of Cambridge, De Montfort University, University of Liverpool, and Royal Veterinary College.
Thank you.
Thank you for listening.
Thank you very much. for your presentation. I have a question from the jury member.
Hello.
Hello. Hi.
Yes.
Ellie and Lily, I have a question.
Okay. Yeah.
What is the maximum possible measurement error in your device?
Well, as we said, with these measurements, they are an estimation from what we already know. However, this device could also be used for research to then overcome this problem, since there are not many studies done into this. However, our product would help with that issue.
Thank you very much.
Thank you. Thank you.
Okay, I also have a question. Thank you for presentation. Could you please describe users' experience? So how these devices should be used? I mean, you have to attach all these devices to all 4 legs, and horse should use it all the time, or how you collect information, how you then make decisions based on this information, all this.
Okay, so when we're talking about tendon boots are used all throughout the equestrian industry, if you like. It's simply just a piece of plastic that will wrap around the front 2 legs of the animal, which are the 2 legs that we're focused on.
Since they do absorb a lot of the force when they do land.
And so the technology will actually be integrated into these boots, and so can just be simply added, attached to the horse in a normal and very easy way. Prior to actually riding the horse, as you've seen in the app design, the rider will be asked to insert everything regarding the weight of the horse, weight of the rider tack, breed, height, and height of the fence.
Which most riders already know. That's
and it's
common
really,
information.
really easy to obtain this. If a rider doesn't know the weight of their horse, you can simply buy a weight tape and calculate it yourself. So it's very, very simple. Then they simply just ride their horse over the course, and the boot will be able to pick up the accelerometry data, compare this to what we've already pre-estimated would be bad for that specific horse, and then compare the 2. And if it is bad, if it is negative and exceeding that benchmark that we have,
the rider would be notified through, let's say, a smart app through a notification. I hope that answers your question.
Yeah, thank you.
Thank you.
Did you make a patent search in this field?
Could you please repeat that?
Did you make a patent search in this field? Searching patent databases.
We did get previously conducted studies. We got one which was done quite recently in 2020. However, not many studies have been done, which is why we did have to estimate a few values. However, this could also be used to find out more about this issue of lameness, and it can be used for research purposes as well. And then this research could then better the understanding of riders, better the technology that could go into horses, better the technology that could go into the industry.
Additionally, like Lily said, there hasn't been any grand scale study regarding accelerometry data, and if there is, it isn't readily available. We've read loads and loads of papers, and a lot of them have concluded that there's very little research into this field, and so we simply see our boot as kind of like the first step in actually overcoming that and bettering our understanding of forces, accelerometry data, and this whole sort of scientific approach to show jumping.
So you see this project as scientific project, not as commercial in the future.
It can be used as both, because there has been, whilst there hasn't been a lot, there still has been some. But once we do get the necessary data, this can be introduced into the market and used as a commercial product, since that we would have accelerometry data for different factors such as breed. And
this product is both commercial and both scientific, because it's enabling riders to, if their horses have injured themselves and are continuing to work that tendon, then they're going to increase the chance of going lame, and then that rider can no longer compete that horse. That's the problem. So we've created this product that's capable of stopping the rider from actually doing that, and allowing a horse a proper amount of rest time, which they don't normally get because they're traveling everywhere, competing everywhere, and jumping all the time. And so even if it's just 2 minutes just to let the tendon rest before starting again, or even if it's just getting off the horse completely, that's what we're preventing. And as well as this, because of the database, because of the tracking and everything, we'd be able to better not only the product, but our understanding.
Thank you.
Thank you.
I have a small question. Do you practice horse riding yourself?
I do, yes.
Oh, yes. Okay. It's very interesting. Thank you.
Thank you.
Yeah. Small question for the ladies. Thank you very much for your very interesting presentation.
Thank you for listening.
Opens up a wide scope of questions and the approach of monitoring these problematic areas, not only in animals but in people too. It's definitely a future of this biotechnology cross field. With your particular device, have you thought about possible scenarios of it failing completely, where the injury will actually occur and the device will not be able to detect that the injury has happened? Like, what would be the conditions that could have be the case?
So now in most of the limbs, in 90% of cases, it's in the lower legs and it's the superficial digital flexor tendon, which is where the boots will be placed. The other 10% are in other limbs. However, this is quite rare in this case. I suppose it won't be able to pick up this, or the battery life may be a problem. However, we have discovered the 1.2 amp 9 volt lithium ion batteries that would have 60 hours continuous use, which is quite a long time. We have quite low power need components, so I don't think that that'll be a massive problem, but yeah.
Yeah, so I think what you're trying to ask is there anything that would go really, really badly and the product wouldn't be able to pick it up? Okay, so simply, horses in show jumping, over time, they've evolved to have tendons that are really, really stretchy. And so they can actually deal with quite a lot of force and shock absorption. The problem is, you could think about it in terms of sort of football and rugby. Every time footballers hit the ball, or every time they're tackled by a rugby player, that's doing some sort of damage. And this is exactly the same principle with horses. Every time they're jumping massive heights and traveling across the world, it is damaging their tendon in some way. And so what we're trying to do is reduce that. So the actual accelerometry data is going to be pretty consistent that we're picking up. And so we do believe that the boot wouldn't have a problem with doing that. There wouldn't be anything that would go.
Yeah. And again, this is like the first step. This is like raising awareness about this as well, because it's such a big problem, but very little solutions for this.
Yeah, I agree. For raising the awareness, definitely is the way forward. But with the device itself, perhaps as future work can look at all possible scenarios, of course, going around the court and maybe kind of hitting something, it turning somewhere.
We have actually thought of that. So in terms of durability, we're aware that the biggest limiting factor to this project is if the horse was to knock a fence down or was to hit the tendon and the technology just completely goes. Therefore, it's just, it has no use. In this case, we obviously want to make it as durable as possible, and we have to look at the certain materials that we would integrate into it. And companies who build tendon boots nowadays, we're beginning to see that sort of innovation. We're beginning to use carbon fiber, Kevlar fiber, things like that. And we definitely use these sorts of materials. Kevlar, which is stronger than steel, really cheap and actually very lightweight, would definitely be integrated to help protect both the tendons and the technology in the boot.
Okay. Well, best of luck. Well done.
Thank you.
All right.
Thank you very much. And Our next participants are from Slovakia. Okay, you can start. Adrian, Patrick.
Hello, can you hear me?
Yes, but I guess I can see you.
Well, can you give us a second? Because if I'm not mistaken, we are presenting on a bit later.
No.
I'm wrong.
Yeah, a bit earlier.
Well,
Your time is 4:50.
All right. Can you give me a second, because we have a bit of technical difficulties due to power outage. So.
Okay. Okay.
Thank you a lot.
If you wish, you can make a presentation a bit later, after a team from Tunisia, if you wish. Patrick, how much time do you need to prepare?
Well, even a minute, because we have a bit of a power outage. So I'm really sorry, but I can present in seconds. So I'm really sorry.
See your presentation.
Well, thank you. Can you even see me? Well, I'm really sorry for a bit of a trouble, but
we had to trouble with
power
time.
outage. I'm sorry. Well, I'm really sorry again. So, dear jury, dear audience, Hello and welcome to our presentation. My name is Adrian.
And my name is Patrick.
And today we would like to show you our project-friendly Dalek, the autonomous robot. In the world of IT and robotics, there is nowadays a great focus on topics like big data, object recognition and autonomous systems and vehicles. One of the key elements of autonomous vehicles is the ability to map their surroundings. To propose, some of them are equipped with the LiDAR technology. Our main goal in this project was to create an autonomous-based vehicle that is capable of autonomous movement and mapping its surroundings. To improve the perception of our robots, we wanted to add object recognition capabilities to our robot that should recognize several important objects that are present in everyday situations and respond to them adequately. Our hypothesis was that the accuracy of the LiDAR and object recognition system will be reduced due to real environment and in movement compared to the simulation environment. The design of the robot is inspired by a character from the British series Doctor Who Dalek, and the main body of the robot consists of completely 3D printed components that are freely available. However, we need to modify those components to confess in our model. We designed the robot's chassis together with the component mounts in the Fusion 360 program, and then 3D printed them out. And after finishing the body of the robot, we had to solve how our robot will be able to function autonomously.
We use LiDAR, light detection and ranging in the method for measuring distances based on the calculation of spreading time of laser beam pulse, which travel at the speed of light reflected from scanned object, which is evaluated in a photodetector. This distance is calculated by integrated microcontroller, whose calculations are based on the signal of main factor of return time. Our robot is using LiDAR H1M8 R5 two-dimensional LiDAR, which has maximum range of 12 meters. Depth shots of roughly 10 centimeters. The main factor of quality of LiDAR-based measurement is quality of reflection, which varies depending on the surface materials of surrounding objects.
On the bottom left of the picture, as you can see right here, you can see the basic view of the LiDAR measurements of the room that we are currently sitting on. And this measurement was done in the static position, which we considered a simulation environment. The picture on the right resembles the mapping of the terrain of the same room. However, on this picture in the program RP Vision, which allows us to store the mapped surroundings and even to project the path which should the robot use if needed. However, we tested our system in real environment, as you can clearly see in the next video. The robot field of view is set, I'm sorry. Yes, the robot field of view is set to 60 degrees in front of him. That means it represents 30 angles on each side. And the objects that he detects should be less than 30 centimeters close, so the robot can respond to them. The robot is choosing direction that is opposite of the detected object to avoid it. As you can see, we put several obstacles in the way of the robot, and we change them to represent the differentiations and his adaptation to the terrain. As we already said, the essential factor for the accuracy of the LiDAR is the surface area of the object, and the flower pots that are glossy black have the worst
quality of surface.
The worst surface to reflect the laser back to its main board. So as you can see, the robot can withstand these difficulties, and the glossy black surface did a bit of irregulation. However, it could still withstand. The next problem was the problematic terrain. After further testing, we decided to prepare our robot to sudden changes in terrain below, such as stairs. The current design of the robot does not allow it to handle such problematic terrain, so we decided to solve this problem by adding IR sensors that they are the safety feature. We place those sensors below the chassis of the robot, and when they detect the empty surface below, they turn the robot back and he backups, turn to appropriate direction as needed, and thus returning to the safe environment.
Objects, another key factor of our robot is object recognition. Object recognition is basically a comparison of learned objects with the objects that are presented in the system. For each item presented, the program calculates the similarity with learned objects and determines its relation in percentage.
The main equipment needed for this, however, is the quality camera that can produce a nice footage. For this reason, we are using full HD camera Logitech C920. However, this footage has to be analyzed. This is done by our main controller board, which is Raspberry Pi. At first, we were experimenting with Raspberry Pi board 3, which wasn't, let's say, powerful enough to analyze the footage and was able to produce only 2 to 3 frames per second for a video recognition. This wasn't enough, so we choose the Raspberry 4 version, which has 2 GB of RAM and helped us improve to analyze the footage up to 5 frames per second, which meet our requirements. An object recognition software decided to use is open source solution that can provide us with customization options that meet our requirements, TensorFlow Lite. We decided to use pre-trained model from Google that recognize approximately 80 objects. And we programmed our robot to audio-visually react to several of them. So let's take a look. However, I would like to have some feedback if you can hear the audio of the video, because we had some technical difficulties before. Well, the first thing that we learned to our robot was a human, which is the most important thing to recognize. The robot must not cause no harm to people, so he avoid them. When it sees human, it asks for identification. However, it doesn't really care much, so he chooses a completely different direction to avoid any kind of person. The cables are only to display as how the robot sees as an output, but it is not necessary for a normal function of a robot.
Stop sign is basic element in the transport, and therefore it was necessary to teach the robot to react in the proper way. When robot recognizes the stop sign,
we're so close though. Yes, here we go.
And stops for a moment and continue the way.
He adds a little comment and then he continues. The last but not least thing that we taught our robot was a teddy bear. This one is just a reminder that our robot is not just a cold piece of plastic. So we decided to detect and befriend some teddy bear animals. He do a little dance, greet his new friend, and then he continue in its path. As you can clearly see, he danced a bit, and he will continue as soon as possible. So for a conclusion, our system for autonomous robot operation in its current body can find use, for example, as a piece of a teaching equipment for understanding the functionality of LiDAR and terrain mapping and demonstration of one of the basic elements of the AI, which is AI vision. Thanks to its eye-catching design, it has power to attract the attention of the students, which can have possibly an interest in those topics. However, its further use can differentiate a bit more, and it could be more complex when the whole system can be transferred to another body or a vehicle, for example, and still be capable of normal function. The complete robot, its current body weighs about 3 kilograms. It's 45 centimeters high, 30 centimeters long, and 25 centimeters wide. On behalf of both of us, I would like to thank you for your attention and for our mistakes and for problems and technical difficulties that we have. And if you have any questions, we will be happy to answer them. Thank you.
Thank you. I will try the virtual background again, but it's very tricky. Oh, I think, oh, now. Okay, now it's okay. Okay, we will end the presentation. Now you can see us.
Thank you very much. Are there any questions?
Okay, I have a question. Thank
Hi.
you for the presentation. It's a good project. Could you please answer what is unique thing for your project? Because, for example, there are many educational tools that can be used by students. There are many toys like this that can interact with objects, with people. Vacuum cleaner can make a map of a room and avoid objects and so on. So all these functions are already realized and already used by different robots for different applications. So what is
well, I have to agree that all of the technologies are already used, for example, in vacuum cleaners. However, we wanted to try to focus our project on the, let's say, the explanation of the LiDAR technology, because it's not very common in here in let's say in our country, and you don't have most of the time the access to such technologies even in the vocational school as we do. So we tried to make something to show this technology that most of our, let's say, people in our age didn't even heard of, and we talked about this a lot. And the most, I think the best thing was that we were able to obtain a semi-quality LiDAR sensor that helped us a lot with measurements that have a bit of a precision.
Yes, we are using not high-end components, we are using low-end components to.
So we try to make it affordable for
Yes.
example, for schools as ours, because this will be the part of the teaching equipment for our school.
Yes, for example, price of these robots can be low as $200.
But it depends, because the main, let's say, expense come from the design, because it has to be eye-catching for students from lower grades. So, for example, when you think about the small children, or not even the small children, for about the, let's say, about 15, 14-year-old child, it can be a box with, or a vacuum cleaner. It is not that interesting when you see a vacuum cleaner, which is, you know, it's nowadays, it's something that is common in some areas.
So your project is an educational tool for school?
Mostly in this design, yes.
Okay.
However, the system can be transferred to something different, and we are planning to, let's say, build a second model, a second version, which will be mostly different in the way of the meaning of the type, how it is even moving, because this is a two-wheeled.
Yes. For example.
Yeah. Stop. Let him go.
Yes. Let me make a small comment. Please think about user's experience. So how it can be used for small grade students or high grade students. So how it can be used in different educational purposes.
Well, we have in our school, it is a quite new subject. It's called robotics, and it is I think its main use is on the lessons on the robotics, because when you can work with such technologies that you cannot before. So I think it's mostly for that. For example, for our school on the subject of the robotics.
It can be programmed in Python, for example.
Well, it can be programmed. You can work with the mapping of the terrain to saving the maps and work with the maps, and even program and prepare the different ways and taught the robot the most different techniques, how to avoid some objects in the way. You can thought in more. That's the point of this robot, that is, it's an educational tool, and it can be, let's say, it has many ways to be improved by students.
Okay.
And to work with it.
Did you think to make it open source project? I mean publicly available with 3D model and some description and documentation?
Yes, we were thinking about this. However, we would like to expand our project to object this as a version 1, and then we would like to hop to version 2 that will be a bit better for public, to have a better documentation to produce it, because this already has some documentation, but it's not good enough to be, I think, open source to be. It could be modified a bit to be open source for the public. And the best thing to being open source for the public is that the public can improve it even more. So yes, we are definitely thinking about it, and we will probably do it very soon.
For example, model must be easier to print.
And even some mechanical parts that we are, for example, the chassis should be or must be a bit easier to print and done.
Thanks for questions.
Guys, thank you for your presentation. It was really interesting. My comment is most related to the Artem questions. So I also had some question to you about the novelty of your research. But now I understood that you're mostly focused on some educational tool, and if it's right, then you should develop, some educational platform to this device. Not use it only as a robot, but together with some educational platform, and it will be really useful.
Yes, that's the future plan of the, let's say, some kind of an application that will help students from mostly the lower grades to work with it easily, because it tends to have some knowledge in, for example, in programming and in electronics to work with it. But that's why we want to make it, let's say, free for the public later to improve this to. It can be more easily workable from the not, let's say, professional public.
Thank you.
Thanks a lot.
Thank you very much.
Thank you.
We have to move on to the next project.
Thank you for the attention. Goodbye.
Goodbye.
Goodbye. Goodbye. Next project is from Tunisia. Okay, you can start.
Just let me share my screen. So hello everyone, my name is Nasreen Qarmani. Sadly, my colleagues couldn't attend, Shaima and Tasneem. They have exams. So our project is the Blind Shine. So one of the most common problems we find is the high percentage of visually impaired people, which reach 6.5 thousand per million population in China and 7.3 thousand per million population in Africa. They try to integrate into society, try to read and write the same as blessed with sight, but sadly, only 20% of blind people can write using Braille, and doing so takes a lot of effort. While Braille technique has existed for many years now, the recent one takes advantage of the easiness of modern technology. As our young scientists and developers, we couldn't stand idle and not involve ourselves in this subject. And this is how our project was born. Blind Shine found the difficulty to communicate with another visually impaired person that doesn't speak the same language. So our purpose was to create an easy-to-use device that transforms vocal messages into Braille printed text. This Braille printer will give blind people the same chances at writing as those without visual disabilities. This device will also be able to detect any language and translate it into Braille in order to ease communication between blind people with different native languages. These are the materials we have used. There are Arduino Uno, ramps board, steppers, drivers, and stops, servo motor, steppers, rods, clamps, lead screw rods, linear bearings, coupler, screws, printer carriage, power supply, and the pillow blocks. These are the realization and implementation of the 3D designs we have used. This is our technical solution. Yes. So our printer is based on a normal printer mechanism. It contains two axes, X and Y. The servo motor turns with specific degree because the method of writing varies from letter to letter. The form of this piece makes the braille needle descend to print characters. The code works by Python programming language. The first step is voice pickup in all language. Second, the speech recognition, then the speech translation. After that, the speech analysis, and the final step is to translate it into braille. This is our diagram, as I said. So we have visited some primary school for the blind in SUS in our country. They used our printer and they were impressed and they preferred to use it. Our printer is a full automatic printer, braille printer. It will help blind people write anything they want just by speaking. It's also compatible with any language, English, French, Spain, Arabic, and even Chinese, thanks to Google Translate services and the API translator. So to conclude, we have successfully created an efficient braille printer that can help blind people the ability to write in braille easily. We can conclude that the system is an extremely beneficial one and a noticeable improvement from its traditional counterpart. Giving blind people this tool will greatly reduce their effort for communication and make them free to write and read without the help of anybody. So our printer is a dream for visually impaired people. And as for future work, one particular feature we're going to focus on is the ability to work on face and object recognition as a scanner to make the visually impaired people read the name of the object and know people's face like anyone else. Thank you for your attention.
Thank you very much for your presentation. Are there any questions?
Yes.
Thank you for the presentation. I have one question. How do you plan to realize this future work? With which tools, I mean?
So we actually didn't think much, but we focused on speech this time. But then we will focus to place such object in front of a camera. Then it will be recognized, and we intend to expand it for future. We haven't already think about it a lot because we focused on the speech recognition and the others this time.
And thank you. And which method do you use for the speech recognition now?
We use the API keys translator.
So you didn't code anything by yourself,
No.
I mean.
We have all programmed it with Python, and we have used API because it's already done.
Yeah, thank you.
Welcome.
Any more questions from the jury members? Well.
Okay,
Artem?
yes, I have
Okay.
a question. Do you have an example of something printed on your printer? So how it looks like?
So we have already tried it in some schools, as I said, and they were impressed. I have a video. I don't know if it was sent or not, but there is it was someone speaks, and it was written in the characters with braille characters. There are points and everywhere. So each character has some points, and they can read it with their hands.
So a blind person can say something, and it will be printed by a printer.
Yes, and in any language, so they can communicate with the other people. And also, for example, when there's any other person, not just blind people, others also may translate it, and then others will read it.
Okay, thank you.
Thank you.
How fast is the printer could print symbols? How much time it takes to print one symbol?
I think
one word or something like that. I don't know how to measure it.
So, for example, we tried hello, and it just got 1 minute, I think, to print it. Or yes, I think that.
1 minute for hello.
Yes, we intend to improve it. And also, our printer will cost only $2,050 compared to regular printers that cost $6,050 because we have used materials.
Thank you.
Welcome.
Thank you very much. And
Thank
today
you.
we have our last project from Nepal.
Thank you all. Goodbye.
Goodbye. Goodbye. Okay, participants from Nepal, you can start.
Good evening, everyone. Can you hear me?
No, we can hear you, but we can't see you.
Just give me a second, please. Now?
Great, we can see you. Yeah.
Good evening, everyone. Can you see my screen?
No.
Now?
Great, now we can see.
Okay. So basically, my project is an augmented reality approach to color blindness. Firstly, starting from what color blindness is, it is basically a deficiency caused by the photoreceptor cells that are present in eye and they're present in eye and sense the wavelengths and send it to retina to make sure that we can detect color properly. But if there's some deficiency or some problem with one or more of the photoreceptor cells, then the eyes are unable to sense the color properly. Despite this disease being diagnosed back in late 17th century, it's still a disease that has no cure, although there are certain market solutions to it. And basically, we all know what's AI. It's a technology that superimposes virtual text, videos, or audios on our human environment, like the real environment. Right now, almost 1 in 20 men and 1 in 200 women suffer from color blindness. That makes it up to 4.5% total in human population. Basically, my project has these 3 constituents modules. The first being the data repository module, the processing module, and finally the module that acts as an output. Okay, first is the data repository module. The light source is configured so that direct light falls into the human's eyes. Adaptable optics elements are placed between the display screen as well as the light source. These adaptable elements act as the calculating instrument for the distortment caused by the deficiency in human eyes. When the light source reaches the screen, basically the beam of the light, how do we explain it? The beam of the light causes the particles to move, and that is why when coming back to the screen, it comes in the form of wave, which is stored as a data in the data repository. Next, we have the local processing module. This module uses the data from the repository module to create an opposite wavefront, which is applied to the deformable mirror. This mirror consists of a very thin layer of flexible metal with numerous small magnets attached to it, so that when we control it, like the controlled wave, so that when the control layer is attached to it, they kind of move up and down, which helps to form the shape of the deformable mirror. This mirror also has a shape of opposite wavefront. So when light from the source is coming, it kind of strikes on the surface, which evens it into a proper image, like a plane surface, and results into a clear image. Lastly, the output module, basically for the correct mirror shape, it's more sophisticated wavefront sensor is employed. A beam splitter is placed in the optical path and used to reflect part of light into a wavefront sensor. This information derived from this contract helps in the wavefront distortion, and this system is in a closed loop. So basically, as soon as the light reaches the frame, the whole three modules work interrelatedly, and at the end, with emission spectrum, the lights are kind of kind of differentiated, and basically the human eye can see the corrected image. Yeah, basically that sums up the project.
Sorry, did you finish?
Yeah, it's done.
Okay. Are there any questions?
I'm sorry. Can you describe? Maybe I didn't catch you well. Is it how do you change the light? How do you change the light finally?
Basically, we do not.
Is it optical? Is it optical effect or programmatical? What is the principle?
So basically, we use the adaptable optics element that kind of filters, like we have these three modules. So at the first, there's this adaptable optics element that are placed between the display frame and the source of light. So when the source of light hits the surface, we kind of calculate the distortion from the data repository module. After that, in the processing module, we make like our glass is made up of like a thin sheet of metal with the magnets on bottom of it. So when light is compressed from the outer surface, it kind of molds into the shape of the what we call conformable mirror. So when light strikes on the valence, since it is already since it gives out the same corrected version of the wavefront, so they kind of even out the surface, and that is how you can see a corrected vision.
You have only model description, or you have prototyping of this device?
So firstly, we did have a prototype for this image, but it was a month ago, and we didn't use adaptable, but we used diffractive elements. But with that, we could see that the color vision was only like it just corrected the red-green color blindness rather than all types of color blindness. So we changed into adaptable optic elements, and with that, the process is still going on.
So do you have any photos or videos of your prototype?
I am not sure if our professor sent it to you. I don't think I have it with me right now.
Could you please speak a little louder? I can't hear you correctly.
I do not have anything to show right now, like as if for now.
What is your plans for future? How you would like to develop this device?
Yes, so with this device, since it's a very small prototype and the device is kind of very not handy for everyday use, so we want to make it sure that it kind of gets embedded in frames that can be used regularly. For that, instead of these optical devices, we are using some diffractive sensors that are honestly only like we are doing a research on it, and even it's not like universally just registered into practical applications, but we are working on it. Plus, we want to work with biosensors so that it kind of gets easy rather than to use 3 kinds of modules. We can embed it into a single one.
Thank you.
Thank you.
Do you have something novelty to patent this, or you use only well-known technologies?
I'm so sorry, I could not get the question.
Do you use well-known technologies, or there is something to be patented?
Honestly, we had to go through a lot of procedures and methodologies to get into one system that could work accurately for all types of color vision deficiencies. And despite we're still trying to figure out better ways, but honestly, this sounds better than all the options we have tried till now.
Thank you.
Thank you so much.
Thank you very much. That's all for today.
Thank you so much. Thank you, everyone.
Thank you. And we can finish our meeting for today. Goodbye to everyone.
Thank you.
Thank you.
Goodbye.
Thank you. Bye
Have a nice
bye.
days.
See you soon.
Bye bye. All the best.
Уважаемый жюри, у меня к
Да,
вам
мы
вопрос.
здесь.
Да,
Мгм.
хорошо, что вы не отключились.
Сейчас отключатся участники, наверное, да?
Не слышно.
Сейчас Татьяна Владимировна ждет, когда
Слушаю.
все уйдут участники, наверное.
Я надеюсь, да, они по-русски. Я сейчас попробую отключить. Всё, никого нет. Мы должны с вами встретиться завтра, обсудить победителей главной награды форума. Вам завтра удобно? В какое время?
Завтра.
У вас сколько?
Можно в пятницу?
Очно, заочно?
Заочно,
В
конечно.
Zoom. Как это называется сейчас? Очно уже, наверное.
Да, определения поменялись.
Я даже сначала растерялась от вопроса.
Какой еще очно?
Да.
Конечно, очно. Но мне удобно после полчетвертого.
4 в 5, да?
Да, в 5 часов удобно.
5 можно.
Нормально, нормально.
5 в пятницу.
К этому времени все
Давай,
протоколы
нет, завтра.
или как?
А, завтра?
Как вообще процедура устроена дальше?
Нужно тогда, если мы встречаемся завтра, нужно мне тогда желательно к утру прислать баллы.
А сколько у нас максимум, Татьяна Владимировна? 100 баллов, да?
100 баллов, да, максимум. Прислать
И
баллы,
вот итоговые баллы или полную разблюдовку по вот этой?
Можно итоговые. Можно
Итоговые.
итоговые, а экспертные карты уже прислать позже. Ну, когда успеете запомнить. Чтобы я свела все в одну таблицу, и у нас с вами была картина, кто на первом, втором, третьем месте. По количеству баллов.
Мгм.
И тогда уже...
Тогда сегодня пришлем.
Отлично. Спасибо, я буду ждать, а завтра тогда я пришлю вам ссылку на Zoom, и в 5 часов завтра мы встречаемся.
Хорошо.
Отлично, супер, договорились.
Татьяна Владимировна, у меня вопрос. Мне нужно по нашим ребятам заполнить итоговую таблицу с дипломами, а у меня нет списка, кто у нас сейчас члены РМПО. Вы можете мне прислать?
Да, пришлю.
Ага.
Всего тогда спасибо всем, до свидания, спасибо большое за
До свидания.
работу. За вопросы, что вы задавали нашим участникам вопросы. Огромное вам спасибо.
Татьяна Владимировна, еще не подскажете, когда у меня пленарное заседание, когда мы делаем доклады?
Пока не скажу.
Ладно, Наталья Юрьевна тогда напишу. Ну все, тогда всем.
Все, всем до свидания.
Хорошо, да, до свидания.
Бай-бай.
Bye-bye.